the papers that I'm familiar with, there's always been some kind of investigator interference. They put leaving groups on to help the RNA couple together, and they block other sites so it makes the right phosphate bond backbone. And so unless you've got graduate students and postdocs working on the early Earth to set up these conditions that were used in the experiments, it's not going to happen.
ID the Future, a podcast about evolution and intelligent design.
By now, you've likely heard about some of the problems facing origin of life studies today. Maybe you've heard Dr. James Tour making the argument that origin of life researchers are nowhere near their goal of creating life in a lab or proving a chemical evolutionary scenario for the origin of life. Welcome to ID the Future. I'm your host, Andrew McDermott. Well, today we're going to hear more from another expert in prebiotic synthesis and origin of life chemistry. His name is Ed Peltzer. In this second half of a conversation with Dr. Casey Luskin, Peltzer discusses some of the problems associated with the RNA world hypothesis, the idea that life may have first emerged through simpler RNA molecules. Peltzer also discusses the debate over the conditions of the early Earth atmosphere and shares his expert opinion on what he thinks that could have been. And if you stick around to the end, he also shares his own censorship story, an all too familiar hazard of the job for scientists who dare to question the standard evolutionary paradigm. Now, let's get back to the conversation with Ed Peltzer and Casey Luskin.
So let's switch over to RNA a little bit, if you don't mind. I don't know if you've looked at the production of RNA. There have been some experiments where they've claimed to be able to produce some of the nucleotides that are obviously necessary for RNA, and this is supposed to help you move towards an RNA world kind of environment for the origin of life. Is it your sense that they have been successful in producing RNA under conditions that simulated the early Earth, or where are we at with regards to producing RNA?
The papers that I'm familiar with, there's always been some kind of investigator interference. They put leaving groups on to help the RNA couple together. And they block other sites so it makes the right phosphate bond backbone. And so, unless you've got graduate students and postdocs working on the early Earth to set up these conditions that were used in the experiments, it's not going to happen. And the other thing is that when RNA is just out there in solution, not in a cell, it has a very short half-life. And the best example of this that people will be familiar with is during COVID. They had an RNA-based vaccine, and the vaccine was shipped frozen because if it was warm, the RNA would break down. And if the vaccine was thawed, it had a very short lifetime. So if they were doing a clinic where they were inoculating people, several times during the day, they would thaw a new batch of vaccine. And the stuff that had been thawed and now was, 4, 6, 8 hours old and warm, they would discard because it had become inactive. So RNA has a very short half-life in terms of its useful activity.
Very interesting. I was aware of the half-life issue, but that's a great practical example of how this comes into play. I mean, that's fascinating, Ed. So, we're probably getting towards the end here, but what is your take on the origin of life? Has there been real progress made by origin of life theorists who are explaining how life might have originated through inorganic, non-biological processes on the prebiotic Earth or maybe in outer space? Are they anywhere close to solving this question?
I would say that what I've seen is a lot of wishful thinking, and they're actually losing ground. And the reason I say they're losing ground is the biochemistry I learned, both in undergraduate school and graduate school, is just a tiny fraction of what we now know. And the complexity of the cell, our knowledge of that, has grown tremendously since I was a graduate student. And so the target, they move the goalposts. The target is much further away. And there is active discussion as to what the actual conditions were on the early Earth. Some people, adhere to the idea that it was a reducing atmosphere, but there are several new camps that say no, it was much more of a neutral atmosphere, and some even say there was an oxidizing atmosphere. And so the starting point, we've lost it. So if you don't know where you're starting and you don't know where you're going, it's hard to get there.
This is a great, I mean, boy, I want to keep going here. Let's talk about the atmosphere for just a minute. I've heard it said exactly what you just said, that the idea that there is a reducing atmosphere on the early Earth that was rich in ammonia, methane, hydrogen, etc., that's no longer favored by geologists. And in fact, I've read papers where they basically have looked at, the gases that come out of volcanoes. And there's good reasons to think that really the mantle has not changed that much over Earth's history to change the gases that are being released from volcanoes. And so what we see coming out of volcanoes today is a lot of carbon dioxide. There is some hydrogen. There is some water vapor as well. That could actually break down into oxygen and possibly give you slightly oxidizing atmosphere. But by and large, I think that the biggest component would be carbon dioxide. Actually, volcanoes are one of the biggest emitters of carbon dioxide on the planet. And so that leads to what I believe a neutral atmosphere. Is that right, Ed? More of a neutral kind of atmosphere.
Yeah, and some people have used the gases from modern volcanoes to justify their idea.
Yeah.
I would say to them, well, that's interesting, but I think you're about 3.8 to 4 billion years too late. Because the gases that are coming up from the mantle are going through, in some places, continental crust, which is highly oxidized. And it's changing as it comes up. Likewise, when we sample hydrothermal vents, the water comes in from the side. It's seawater. It comes in from the side. It gets warmed up. That makes it lighter, and it can rise and come out the vent. But in that process, it's altered. Because the water we see coming out of hydrothermal vents doesn't have the compounds that it had when it went in. All the organic compounds are destroyed. And the composition of gases is highly influenced by the gases that were in the seawater when it went down in the cracks on the side of the ridges. So what you're looking at isn't pure mantle gases. What you're looking at is gases that have been heavily modified by the crust that they're going through, whether it's oceanic or continental crust.
That's a fair point. So what does that tell you then? I mean, what would you predict the early Earth's atmosphere would have looked like? Obviously, that was maybe before there was continental crust, and maybe there was a different composition. What is your proposal of what the earlier gases coming from volcanoes might have been?
Well, it's been pointed out that hydrogen is the most abundant atom in the universe. The Earth's core, the metals there, are they're metallic. They're reduced. They're not oxidized. So we have the idea that in the beginning, as the Earth was coming together, things were very much reduced. I think Howard earlier was right. Now, when the sun lit up, it could have easily blown that early atmosphere away. But what came back out, you still have a very reduced planet. And, you still see when you get samples from the deep mantle, things that are heavily reduced.
So you think there could have been a reducing atmosphere on the early Earth? Possibly.
Yeah.
Okay.
And some people argue when they build the neutral atmosphere, they talk about water reacting with graphite, and this makes CO, and you run it through a second time and you get CO2. And while that is true, their equation isn't balanced because there was hydrogen in that water. And so when the carbon in the graphite picks up the oxygen to make carbon monoxide or carbon dioxide, each of those passes releases a molecule of hydrogen. So while you're generating CO and CO2 for your atmosphere, you're also generating hydrogen. Now, hydrogen will escape the space, but not right away. It has to diffuse to the upper atmosphere and then slowly be lost.
Yeah, hydrogen is probably the best bet for having a reducing atmosphere on the early Earth. I would agree with you on that. It does get stripped away over time, but maybe it was there. Yeah.
Yeah. And hydrogen can react with CO to make formaldehyde, right? And so you're going, in this process, you're going to reduce a lot of things. So the idea that the Earth was, oxidizing, I think it's got problems.
Okay. Great to hear your expert opinion, Ed. So maybe they could produce amino acids and some of these, organic molecules. But I think you've given us a nice survey of why, even if they were produced, it's not going towards life. In fact, go ahead.
Well, what I was going to say is one of the things I did as a graduate student is I took, I think it was a piece of green schist. It was 3.8 billion years old or whatever. And the idea was if we could dissolve the rock, we could look at the organic matrix that was in it. And when we did that, we dissolved the rock with hydrofluoric acid. What was left behind were these tiny little bits of black tar. And we did an analysis looking for amino acids and hydroxy acids. And what we found was terrestrial contamination. A rock can't sit around for 3.8 billion years on the Earth and not see. It suggests to me that, yes, on the early Earth and in the reducing atmosphere, you can make a lot of organic molecules, but the organic molecules, they don't separate into compound classes. They're mixed. I've never seen a mixture unmix spontaneously. And when they mix, these are reactive chemicals, and they're very promiscuous. The amino acids react with sugars and fatty acids and aldehydes, and you get what are called the geomolecules. The humic acids, the fulvic acids, the melanoids. And you don't get the biomolecules that you need for the first cell.
You don't just get I think that probably is a misconception people have, that these experiments, miliary experiments, what you find in the meteorites, it's not just a pure mixture of amino acids. It's a lot of different molecules, and that's a problem. I remember I took a seminar from Stanley Miller when I was at UC San Diego, and I remember him telling the class, I still have it in my notes, that making compounds and making life are two very different things. And he said that on a number of different occasions over the years. I've seen him quoted to that effect in other places. And that's exactly right. He was very open about that. And I think that's probably a good place to leave it, actually. We've made some compounds, but we're nowhere near making life. There's a lot of obstacles that have still not been overcome. Here we are, 75 or so years later.
Casey, I'm reminded of a quote I heard from Lynn Margulis, a noted biologist. And her comment was that the distance between the organic molecules that you can produce in miliary-type experiments and the first living organisms is vastly greater than the distance between that first organism and man.
Wow, that's amazing. And what a great quote to end this conversation on, Ed. We've corresponded for many years, and for many years we've talked about your interest in intelligent design, your skepticism of the mainstream view of the origin of life and the whole project. And I want folks to know that, there's not only one Ed Peltzer out there. There's a lot of folks out there that we've had as sort of fellow travelers with the ID world over the years. And some of them have been able to come out of the closet, but a lot of them have not. A lot of folks are still undercover. A lot of folks are still very junior in their careers. So I just want to encourage folks that, you can reach the point of Ed Peltzer, but even you, Ed, you had to wait a long time to get to this point where you can really speak out freely. Would you say that?
Yeah, there was after one of the ID conferences, I think it was after the Kansas one, I got some pushback from a very pro-evolution scientist. And he wrote to the director of Mabari at the time to try and get me either censored or fired, or was certainly trying to embarrass me and to embarrass the institution. And she asked me to write to this guy and take Mabari off his website. And so I did, and I copied her on the letter, and he wrote back a very nasty letter that he was not going to do it. And this just showed to our director the kind of people I was dealing with. And, I appealed to him a second time. And what he did is he took everything off his website. But he said, if you want to know where Ed works, you can do a web search and you'll find him. So there is an effort by people that don't want ideas contrary to what they believe out there, and they will do nasty things to discourage people from speaking up.
Wow, Ed, I don't think I knew that story. And this is basically an effort to actively punish you because you expressed your scientific views that the origin of life has scientific problems. And you were not allowed to do that. They tried to actually harm your career, harm your employer, and censor you. And wow, I did not know that story. I mean, we've heard so many stories like this over the years. I couldn't even begin to try to count them. But I mean, you've just given us a little sense of what people are up against. So, I mean, thank you, Ed, for your courage in speaking out now. And I hope that no harm comes to you at this stage of your career.
Well, I'm pretty untouchable now.
There's always a way they can get you, Ed. I mean, they could, I don't know what they could do. They could call your electric bill supplier or something. I don't know what they could do, but they could do something. Call your dentist.
Yeah. I'll let God be my protector.
Fair enough, Ed. Okay. Well, this is Casey Luskin with ID the Future. Let's take an ending again here. Is that okay? I just want to came off a little bit odd.
Yeah.
How should we put this? I'll just take back after you said your piece, and I'll say that again. Okay. Wow, Ed, I don't think I ever heard you tell that story, and that's really quite striking that there were people out there that were trying to actively punish you and censor you for speaking out on your views, basically against the mainstream view of the origin of life. So I just want to say thank you for your courage over the years and what you have been through and what you've done to try to speak the truth on these issues.
Oh, thank you, Casey. The thing I remember is that when people don't have a rebuttal for your argument, their tactic of last resort is the ad hominem attack. And when you hear that, you know you've won.
Mm. That's a great point to remember when we're in these sort of controversial dialogues. If people had a good response, they wouldn't be calling you names. They wouldn't be trying to silence and suppress you. And so although it's not a fun thing to go through, I mean, I've been through this as well. It's not fun to go through it. In a weird way, you can kind of be encouraged that if your intellectual, opponents had a good argument in response, that's what you would be hearing. You wouldn't be getting this kind of a response. So Ed, thanks for putting up with some of this, unfortunate, unpleasant experiences you've had over the years. And we do hope to have you back on in the future.
Thank you very much, Casey. It's been fun and my pleasure to be here.
Well, I'm Casey Luskin with ID the Future, and this is just a reminder that there are other scientists out there like Ed Peltzer who are critics of the mainstream materialistic view. They just don't have the academic freedom to speak out. And we hope that you'll be encouraged by this interview today. Thanks for listening.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.